All right. Good morning, good afternoon, or good evening, depending on where you're joining us from. We're just going to give it a couple minutes to let people join, and then we'll kick off the webinar. And while we're waiting, if you're ready, Caitlin, we've got a poll that you guys can chime in on, just so we can all get to know each other a little bit better. Just asking kind of what you do, and then if you would like, you can drop in the chat where you're tuning in from, or air any grievances that you have about the Super Bowl. That's what we were chatting about right before this. If you're joining us on LinkedIn, you won't be able to see the poll, but please feel free to drop what your role is at your company in the chat, and where you're tuning in from, any grievances you have about the Super Bowl. We listen and don't judge. This is a safe space. So, and we'll just give it a few minutes before we get started.
This is great. We've got a nice mixed crowd. Looks like we are about 40% engineering, which is a pretty good lead in engineering and DevOps, and quite a few from AppSec as well. By the way, I'm calling in today myself from Denver, Colorado, and it's just starting to snow here. We've had really a pretty warm winter, honestly, but so it's really nice to see some snow rolling in finally. Where's everybody else coming in from? Where's the weather where you are? Chime in the chat. Let us know where you're coming from. Folsom, California. Very nice.
I'm in Huntington Beach myself, so.
Chicago, Illinois.
Chicago's getting snow tomorrow.
Yeah. We've got one person from Chicago.
Oh, that's right, we do. Is there anywhere to ski in Chicago?
Boy, Illinois? I feel like Illinois is like as flat as a pane of glass. Am I wrong on that?
I know we had skiing in Minnesota.
Very flat, yeah.
So
yeah.
You can do it there, you can do it anywhere.
Right.
Find a golf course with some hills.
A nice hill to get started.
How it is.
I lived in Illinois for a while. I lived in Urbana, Illinois for some time, and I was really into biking. I had moved there from Georgia, where it was a little bit more, there's a little bit more interesting aspects to the landscape in Georgia. Lots of, because I was doing motocross biking, and it was tons of fun. But got to Illinois, it was very flat, but I got into 10-speed biking, and it was wonderful because you could go for miles and miles. We actually, some friends of mine and I would ride our bikes to Indiana and back, and we'd go camping in Indiana. But it was wonderful because you could just go forever and there were no hills to contend with.
That would be my kind of biking. And running. Flat.
Also a good spot for cross-country skiing. So if you're not into downhill, that's too fast and exciting for you. There's definitely a lot of good cross-country in the Midwest.
Cross-country works muscles I didn't even know I had. That is a whole different experience. All right, well, we are 4 after, so we'll go ahead and get started. Thank you everyone for joining today. And thank you to our hosts, April and Brian. Thanks for taking time out of your busy schedules, as well as everyone else who is here today. So they're going to talk about how StackHawk and GitHub work together to help you obliterate security bugs. We've got a lot of really cool integrations with GitHub. They're one of our favorite partners. And And so there's all kinds of different mechanisms to help you find and fix vulnerabilities throughout your software development lifecycle. So I will hand it over to them to get started. Sorry, one more housekeeping item. Everybody will receive the recording and the slide deck after this via email. So just in case you miss anything, you can catch up later when you receive those items. So over to you, Brian and April.
All right, so here we are talking about obliterating security bugs with StackHawk and GitHub, and really how these two platforms come together to provide a really excellent shift-left application security platform. And so to start us off, I'd like to give you a visual of what it looks like to obliterate security bugs with StackHawk and GitHub. And it looks like this. All right, if I could hear the crowd, I know you would all be
I
laughing.
needed the sound effects for that.
The crowd goes wild.
Crowd goes wild.
Awesome.
So,
well, yeah, like let me get us started. It's a tough act to follow that marmot, but we'll go with a bit of a quick introduction to StackHawk and kind of why we built it. So we were founded in 2019 in our mission to revolutionize automated API security testing. And to do that, we, from the very beginning, focused on making security testing fast, automated, and built for developers. One of the biggest challenges with traditional DAST or dynamic security testing is it's really mostly been too slow or too complex to fit into a modern development workflow. And that's why StackHawk is different. We're the only DAST solution fast enough to run inside CI/CD pipelines, meaning that security testing can happen before code is deployed to production. And unlike traditional security tools that slow development down, we're designed for developers, but we still provide that deep security insight that teams need to protect all their applications. So I think before we go further, let's do another poll. Can you give us a sense just where everyone's at when it comes to DAST and security testing? How familiar are you with it? It looks like we've got a decent amount of folks who are familiar with it, either very familiar or have checked it out, but kind of covering a pretty good spectrum of a little familiarity to deep experts. So that's great.
yeah, that's great. So far, it looks like we don't have anybody on the call that hasn't at least heard of DAST and has some familiarity with it.
Cool. So yeah, April, do you want to kick us off and walk us through the differences between all these different security tools that we're going to talk about today?
Sure. Yeah, so DAST typically fits into what I'd call a well-balanced diet of application security test tools. We're off to the right here. So overall, these tend to be the most popular kinds of testing tools when you're talking about application security testing. Security composition analysis, or SCA, static application security testing, or SAST, and dynamic API and application security, DAST. So on the SCA side, GitHub provides a tool called Dependabot that a lot of you may be familiar with. And really what it does is it looks at all of the dependencies that your project pulls in and analyzes those for known vulnerabilities. And so there's a whole catalog of CVEs of known software defects among a lot of popular libraries and components that people pull into their products all the time, open source projects. And SCA is a really fast way of just going through the ones that you're pulling in and saying, hey, these have known vulnerabilities. You should resolve those really quickly. This is a fantastic form of testing. It does tend to be kind of noisy because there are a lot of dependencies these days that people pull in, and there are a lot of vulnerabilities, and they happen pretty frequently. One advantage of this tool also is that there's not really any false positives. It's always true whenever they flag a problem, and often the resolution is also very easy. In fact, Dependabot, like other tools, can actually open pull requests for you to to fix the vulnerability. And if you've got good testing in place in your CI/CD pipelines, as you should, then it can actually open that pull request and show you test results that prove that it's going to be okay if you merge it. Next is SAST, and GitHub provides another excellent tool called CodeQL. And the way SAST works is that it also looks at your static code. It actually analyzes your code base and looks for code patterns or code smells that could indicate that you may produce a runtime vulnerability. So, for instance, it can identify where you've got variables that are inputted by users and then used in important critical potentially data changing operations, but they haven't been checked for problems that could cause security vulnerabilities, such as SQL injection attacks. These are really nice. They tend to be a little bit slower than SCA. But rather than looking at your dependencies, of course, it's telling you about your code base and it's finding your bugs. And when they give you results, those results are very actionable. They can show you exactly where in the code base the supposed problem is. And that's really helpful for developers who want to resolve those vulnerabilities. A downside of this tool is that it too is rather noisy because it's showing you bad patterns, but not necessarily real runtime vulnerabilities. And that's where DAST comes in. DAST operates on your running code. So you actually need to have your web application up and running in order to use DAST. And then when you run a DAST scan against that running application, you're actually attacking the application and trying to exploit vulnerabilities. So when we find things, they are provably runtime vulnerabilities. We're going to show you the evidence that we were able to exploit that bug. And we're also going to give you the information that you need to be able to reproduce that vulnerability. So you can run your code and you can try that same attack yourself, reproduce the issue, and start working on a fix. One of the disadvantages is that we aren't showing you your code base. We can't point to the exact file. But this is where having a platform like StackHawk and GitHub together comes in really handy, because we can combine these tools and correlate these results and give you that full picture of runtime vulnerabilities where you need to prioritize those fixes, all the way down to static analysis that shows you where exactly those runtime vulnerabilities manifest in code. So Brian will take us from here to an overview of our integrations with GitHub that enable these kinds of features.
Awesome. Thanks, April. So yeah, let's kind of transition into the main focus of today's webinar, or office hours, I should say, how StackHawk and GitHub achieve developer-first API security testing together. So it really starts at this top left with API discovery. StackHawk can connect to your source code repositories, whether it be GitHub or any other source code management system, and identify the applications and APIs in your organization that gives security teams a better oversight and governance over what needs to be tested. It also helps detect new APIs as they emerge. So when that sort of side project becomes code deployed to production, you knew about it before it ever got into production. And then moving into GitHub Actions is really, how do we automate security testing in the CI/CD pipeline, making sure that that testing is seamless within that development workflow. And then when we have those findings, instead of requiring developers to go check a bunch of external platforms, those test results are delivered directly into the PR comments and surfaced in GitHub Advanced Security in that dashboard to make sure you see all your vulnerabilities in a single location. And lastly, as April mentioned, one of the downsides of DAST is it doesn't tend to give you a particular place in the code where the finding was discovered. But when we combine DAST and SAST findings, we can correlate that dynamic result with the static result from CodeQL. And that gives developers a way to identify exploitable vulnerabilities and pinpoint exactly where in the code to help them get it fixed faster. So now let's kind of dive into each of these. But before we get into that, April, do you want to kick off our next poll question for us?
I was muted, of course. All right, so thank you, Brian. So our next question is, how confident are you in your understanding of your API attack surface and its rate of change? Are you deep in it and you know exactly how often people are changing code and producing APIs and adding to your attack surface? Or are you testing about 50% or more? Have you covered most areas, or do you have some uncertainty about how much of your attack surface you are covering with good application security testing?
Yeah, I think, April, one of the biggest challenges that I know I've heard from customers is just simply figuring out like which APIs that you have. We've worked with teams who've spent months or even a year trying to piece together how those APIs, which APIs are running in their environment.
Yeah.
A lot of times they do it with a spreadsheet, I think, and that really creates a challenge of chasing down developers and trying to track down what repositories are actually have APIs. And as we know, I think APIs are really everywhere now. They're powering your applications, obviously, but they're connecting microservices, enabling integrations, and it can really be a blind spot. And so that's why we built API Discovery to really automate this process and give security teams a full view of what APIs that they have and where they are. And so it's really simple. We connect to your GitHub repository and scan the repositories for API related code, automatically identifying which are web applications and APIs that need testing. So that takes out that manual tracking and gives you a real-time view of your API landscape. It helps teams focus on the most critical areas first. So we help prioritize which things that you should focus on, and also helps enable informed discussions between security and development teams about like what needs to be tested. You kind of come as an AppSec professional, you can come informed about this repository, bring that to the team and have a discussion about it. It also gives leadership a visibility into security coverage, so we can see for compliance and reporting needs that you're covering everything. And lastly, we can help identify new APIs before they reach production. So you're not putting code out there, exposing endpoints that maybe no one in your organization knows about, but that's the type of thing that can be exploited. So now that we've identified like what needs to be tested, let's talk about how do we get these actually tested. So April, do you want to walk us through how we integrate with GitHub Actions?
Yes, I would like to do that. I do want to mention, though, that our poll results have rolled in, and this crowd reflects a lot of what we see in the industry, which is that most people really don't have 100% confidence in that they know exactly what their attack surface is and all of the APIs that are out there. So this is a key feature that would help in performing that analysis for you. And so once we know exactly how many APIs we've got out there, and we've got a test program in place, and we know the universe of APIs that we want to test, how do we get them under test? And this leads to our next integration with GitHub, which is the HawkScan action. So GitHub has a CI/CD tool called GitHub Actions, and it's really a beautiful system. It's very simple to operate. It's very commonly used. We can integrate really with any kind of CI/CD system or really any kind of QA automation system. But we have a deep integration with with GitHub Actions. We've built our own action. And so you can see this is what it typically looks like in a workflow. So in GitHub Actions, you define workflows that typically go through a similar or pipeline is this. Check out your code base, install, Node in this case, or whatever language tools you need, install the dependencies for your app, build it, run some unit tests, and then you can actually run the application right on the pipeline agent. So in this case, this application has been started and it's running as a daemon in the background. And so this web application is now exposed. And then we're going to run HawkScan with the GitHub HawkScan action. And this scanner is going to run right there on the build agent, right where the application is running. It's going to attack it and produce a scan result. And because of the speed of StackHawk, typically this scan is going to take a few minutes. And typically we're shooting for about 5 to 10 minutes so that your pull requests or deployments don't take too long, including testing. And then we'll produce results. In this case, you're seeing the results in the console, but of course we can also see them in the StackHawk console and in other places. We can surface those scan results directly in GitHub in pull requests and in the GitHub security dashboard, and of course on our own platform. So that's GitHub Actions. That's our HawkScan action, and it's really a great place to get started with automating DAST scanning in your build pipelines. Next, I want to turn back to Brian for pull request checks.
Awesome. Thanks, April. Yeah, so when we're talking, just as April was showing about getting into the developer workflow, scans happening as every PR is created, it's important that we provide that security information at the right time and in the right place. So, as we all know, developers shouldn't and really won't leave their existing workflow or jump between multiple tools to check security results. And that's where the pull request check integration comes in. So with the StackHawk's PR integration, we can update that GitHub action that April just showed to connect security tests directly to a specific branch and pull request. So that, when a developer is pushing code, our security testing happens automatically in the pipeline, and the results are surfaced directly in the PR itself. So instead of requiring developers to go out to that other platform to find out what happened, we bring those right into their workflow. So what does that look like? Developers see the security test results as soon as they open a PR. The comment contains everything they need. So it's whether the vulnerabilities were found, where they exist, and even how to fix them. And then developers can just make those necessary fixes, rerun the test, and confidently merge their PR, knowing that those issues are addressed. And again, not having to go into a separate tool or dig through logs. Those findings are in the same place the developers are working. So speaking of getting those findings out of our platform, April, how do we get these security insights inside a tool like GitHub Advanced Security?
Well, we worked with GitHub and Microsoft to update the standard that they use, which is called the Serif file standard, stack analysis results information format. I think that's what it stands for.
Rolls off the tongue.
Rolls right off the tongue. So they use that to post results of their static analysis tools to their security dashboard. So this is what it looks like in GitHub to look at the security dashboard and see the findings. We worked with them to update that standard so it could also take dynamic results from dynamic test tools such as ours. And so that's how we're posting to their dashboard as well. And the result is, again, a developer never really needs to leave the comfortable home of GitHub where they work every day already to see the results from our tool. So they can see at a glance that from the security dashboard, that tab's got a big number by it. They can go check it out and see findings not only from CodeQL, but also from StackHawk. And again, it's just about keeping them in context, maintaining that context, and reducing fatigue from having to jump from platform to platform, just trying to make their job easier and also draw them into the job of application security. we really believe that not only AppSec engineers, but developers should be involved in this and should play a role in it. So if you think about it, they're in a really unique position to be able to affect it. And with our tool and with tools like GitHub, they're in a good position also to contribute to the testing of their own applications. Next, let's talk about CodeQL integration.
So we talked a bit about this already, but let's take a deeper look at how we combine the static analysis or SAST findings and dynamic findings to provide that complete picture of security vulnerabilities. So as we talked about with static analysis earlier, they can produce a large number of findings, but really the challenge becomes which ones are actually exploitable in my live environment, right? If I get 2,000 SAST findings, it can be hard to figure out where to focus, which ones are going to give you an actual meaningful result. So that's where the StackHawk integration with GitHub CodeQL comes in. We're combining the results of those dynamic tests to confirm that the vulnerabilities are actually exploitable. And with the combination of the CodeQL static analysis, we can pinpoint where the issue exists in the source code and get that kind of connect the dots between detection and remediation. So how does this work? We find the vulnerabilities that can actually be exploited using StackHawk. CodeQL identifies where in the code that the finding is, so that, again, developers don't need to switch between multiple platforms. They get those actionable security findings. And as we mentioned before, because we have this integration into the pipeline, developers can just easily make that fix, rerun the test, and merge their changes confidently. So nothing is going out to production without being tested and remediated. So now that we've kind of talked about the whole picture, let's kind of see how many of you are actually using GitHub Advanced Security. Maybe you're considering adopting it. Kind of curious how widely used it is.
All right, got answers rolling in. I'm eager to see the results of this. Looks like we've got a lot of folks who have at least heard of it, and many who are planning to use it, and quite a few, at least just about 50%, are actually using it today from our respondents so far. It's a very popular tool. I've used a lot of CI/CD tools myself. A lot of my background is in DevOps and SRE, and of the tools that I've used, I think it's probably my favorite. While those results are continuing to come in, I want to start showing you a demo of all of these things that we've talked about today. API discovery with GitHub, our GitHub Actions integration, pull request checks, the security dashboard in GitHub, and our CodeQL integration. So to start off, I want to show you what it actually looks like to use our API discovery feature. I have switched over to our web console, and this is where typically we're showing you all of our scan results, all of the applications in your system, all of our high-level reporting that we provide. But often the job of an AppSec engineer who starts to use StackHawk, that job starts here in API discovery. And it's a really simple process. I won't show you, but essentially in GitHub, you know that you can install applications from the marketplace, from the GitHub marketplace. Well, you can also install StackHawk from the GitHub marketplace. And when you do, one of the features that we'll enable is that for every repo that you've given us access to, we will go through and analyze those repos. It's actually a pretty light touch. We're just looking at file names. And we'll identify those repositories that have testable web APIs and web applications in them. So you can see from this view, in our attack surface view, all of the repos that we've identified that have testable web apps in them are marked with a purple sparkle. And you can, from this column, you can either view that application and what your testing looks like today. So this is that application Java Spring Boney in multiple environments. This blue tag is an environment name. And so I'm testing this in multiple environments. And in each one of those, you can see this GitHub Actions environment. I've actually got a scan from earlier today. Back to the API discovery page. If I have not connected that application yet, I can connect it from here. I can create a new application in StackHawk, and this will take me through a wizard that will help me describe the application and come up with a good configuration for me so that we can begin testing. And then as I add applications to the platform and start testing them, they'll show up as covered in my attack surface coverage. So in my case, I've exposed actually more than 12. It's just that the system has identified that 12 of my repos, of my 14 repos, have testable web apps in them. And of those 12, I've got 3 under test, and that means I've got 38% coverage of all of my APIs. So I've got a little ways to go. But this view gives you a really nice analysis of where you're at in your testing and what the universe of applications is that you need to get under test in order to have full coverage. And as Brian mentioned before, we're also telling you about frameworks that we detected, last commit times, sort of frequency or volume of commit activity, and even who made the most recent commits in these repositories. And that gives you a basis to start to talk to developers if you want to and if you need to help get these applications under test, because often developers know a great deal about these applications and it can be useful to consult with them. So that's API discovery. Next, I want to show you GitHub Actions. And to do that, I'm switching over now to my GitHub dashboard. So in GitHub, this repository, which I mentioned before, and I showed you some of the test results for, is called Java Spring Boney. And it's an application I test every day because I demonstrate this every day. In this code base, I've got a number of files. Most of these are code related to the application itself. I've also got a StackHawk configuration file that defines how this scan is supposed to run. And it doesn't always need to be this complicated. Usually you start with just a few lines of configuration to say, here's the application that I want to scan, the host I'm going to scan it on, and the development, or in this case, development environment that I'm going to scan it in. But I want to go back to this directory here, which is where GitHub stores its workflow files that define GitHub Actions. So in this case, I'm showing you a workflow that, as I mentioned before in the slide deck, it creates a job, it checks out this code base, it sets up, in my case, I'm using Docker to build this application, but it doesn't matter how you do it. It runs the application, and then it runs HawkScan against it. And so this, I know, is a little bit of an eye chart. It's kind of a lot of detail, but suffice to say, our action makes it very easy to define a scan and enable it in a CI/CD automation run. In this case, this is going to run on a pull request. So I want to jump over to my pull requests where this ran earlier this morning. I opened a pull request. And as that came through, when I checked in code to this pull request, that pipeline that I was just showing you ran. And when it ran, it got a scan. And here are the scan results. So this is our pull request integration, showing how we can post our scan results back to the pull request. And this page, although it may or may not be familiar to you, this is a page that developers are looking at every single day. And so if a developer came across this in their pull request, they might be surprised to see that there's a new vulnerability that we found. And we set a threshold that says, if we find any new high severity issues marked by this red H, and we found 6 high severity issues. We're going to fail that check. And so that actually broke my pull request. And this is the test that failed, the Hawk scan check. And so from here, I can actually jump out to the scan results in our platform. But before I do that, I just want to also point out that in this view, you can even see all of the details. So we found a SQL injection vulnerability. It's a high severity issue. We found it on multiple paths. And so again, a developer can see at a glance what this scan is telling them. Before I jump out to the full scan results, I want to show you also the security dashboard. We mentioned this dashboard integration, and under security in the code scanning section, typically you would see CodeQL findings. And so these are all of my CodeQL findings. But we can also look at, in this case, StackHawk findings. So all of the dynamic scan results are posted here to this dashboard as well. Again, just another way to meet developers where they are. And they're definitely in the GitHub dashboard all day long. So back to this pull request. Say I'm a developer, I open this pull request, it broke. I can't move forward until I address this failed check. So I'm going to jump out to the details here, which will pull me into the StackHawk UI. So from the StackHawk UI, I can see this is my test result for Java Spring Only, the application I just tested, in the GitHub Actions environment. And I can see that I've got 7 different types of findings: SQL injection, proxy disclosure, etc. And I can see the criticality of those findings and how many findings there are that we regard as new. There's also a SAST column. And so under the SAST column, with SQL injection and secure flag, cookie with secure flag, there's a little GitHub icon. And that GitHub icon indicates that I've got SAST correlated findings. So now I can jump into these findings, and just to orient you to this screen, this is the detail around the SQL injection finding type. So we found, again, six routes where we were able to exploit a SQL injection vulnerability. One is this search path that's got a post method, and several others are simple get methods with parameters. At the top, we've got comprehensive advice for a developer that shows them how to fix this problem and accomplish the same thing they were trying to do, but with code that won't produce this SQL injection vulnerability. Then on the right, for each one of these findings, we're pulling up some detail about that finding. So going back to this post request, this is the request that the scanner sent to the web application during the test, including all of the request headers and the request body, which in this case was a search text field that we posted some data to. And what we posted was this single quote, which is often the beginning of a SQL injection attack. And the response we got, the evidence we got back, was a Postgres exception. And in the response tab, we've got that detail again. Here's the response headers that the application sent back to the scanner in response to the request. And here is the response body, which includes this Postgres exception text. So this is how you know this is our evidence that it's a real vulnerability. A developer or an AppSec engineer can also use this validate button to generate a curl command to reproduce this attack. So they can come back to their workstation, reproduce the attack, verify that they're seeing the same thing that our scanner is, and start working on a fix. Here's where the CodeQL integration comes in. This CodeQL tab surfaces those results from GitHub CodeQL, which is their static analysis tool. And so we are able to surface then the code that they found. So they found that in this file, on this line, there is a query that's, in this case, made up of a user inputted variable that we did not check adequately for characters that can be used in a SQL injection attack. So this points the developer exactly to the files and the lines that they should be concentrating on. And that's just immensely useful. So now we can tell them, this is definitely a runtime vulnerability. We can help you reproduce that finding, and we can point you to the code that is most likely implicated in this same vulnerability. And of course, we can jump out to the details in CodeQL from this button as well. So here's that same finding in CodeQL on the GitHub platform, and it describes typically a great amount of detail around this bug and what they found. But again, static analysis is going to produce a lot of results, and they're not all runtime vulnerabilities. This is just a way of combining the two tools and giving you the best of both worlds. So that is our demo. And now I'd like to invite questions and answers. I haven't been watching. I don't know if there's, I don't know if there are some questions out there already, but this is typically where we would be.
Yeah, we've had a couple. I think Tim in the chat asked about if we are working with MuleSoft. Eric had a great answer, just that we're not technically in a partnership with MuleSoft, but you can export the OpenAPI spec / Swagger artifacts and bring those into StackHawk to help define the API so that our scanner can detect all the different paths that you have in your API. So, and we can do that with a number of other tools. You can also connect up to your Selenium or Cypress testing suite to help. And really one of the important aspects of dynamic testing is that idea of what are all the different endpoints that exist in an API. And so we have a number of different ways to bring in external sources for discovering all of your endpoints.
And I know a lot of MuleSoft users, especially if you've been with MuleSoft for some time, often are developing an API around their proprietary specification, RAML. I know that there are tools out there that can convert RAML to Swagger docs or OpenAPI specifications. And we do have a couple of customers who use MuleSoft very effectively with StackHawk. It's a great question. And that's a great point, Brian. OpenAPI specs are not the only type of API documentation that we can read in. We are very API focused. We think that rather than scanning the whole website, it's much more valuable to scan individual APIs that serve the website, which is often the case in modern application architectures, because then you can get down to an individual API that a developer is working on, get a really comprehensive scan of that API, and surface those results back to them, either in a QA automation workflow, or better yet, a pull request workflow where you can interrupt the developer and let them know and pull them into those security findings right away and help them fix those vulnerabilities in the middle of their SDLC, long before that application ever makes it to production. Any other questions before we close out?
We've got one, maybe you can help answer, April, is how is StackHawk different than Burp Suite?
It's a great question. It's a great question. And I think Eric's got a great talk track around this. In my view, Burp Suite is a really excellent penetration testing tool. It gives you a lot of tools to explore web applications and try different things to attack them. It's a wonderful companion to a skilled penetration tester, but it's not really built for the kind of testing that we do in automation runs and pull request runs. It's typically used outside of the organization, looking into the organization. It's a tool that requires a lot of security expertise to get into, and it just doesn't automate very well, and it doesn't scan very quickly. So the difference that StackHawk brings is that we're able to really integrate into SDLC workflows in a meaningful way. We're much, much faster, and we're much more focused on modern architectures, REST APIs, gRPC, GraphQL, those sorts of applications. So the key with us is the ability to test frequently, very quickly, achieve wide coverage across the organization, very deep coverage within each API, and do that in automation in a way that is meaningful to developers, and even involve developers in testing. Because our tool is built for developers first, it's very approachable by developers, very easy for them to get involved in the testing themselves. And we find that when you involve engineers that way, especially with StackHawk, they really like what they see, and they start to regard StackHawk as not just a DAST testing tool, but a different kind of code quality check that they can integrate into their own development practices.
Another question in chat. I think we covered this earlier, but just to kind of clarify, the question is StackHawk, does StackHawk combine SAST and DAST? I think same question earlier that I answered in the chat was just, as we talked about, StackHawk is not a SAST tool, but it does combine the dynamic testing DAST results with static results. As April just showed, the integration with CodeQL allows us to combine those results and give you not only the pinpoint accuracy of where the finding exists in the code, but also that it's exploitable in the running application, which is super important.
So coming back to this view where we see the dynamic result over to the left and those static analysis results correlated and pulled in.
So thanks for all the questions in it. Let's keep them coming. If anybody has any others, we'd happy to dig into them.
Seems like that's about it. Thanks everybody for showing up. Really, it has been a pleasure to share this with you. I hope everybody got something out of it. Oh, one more question. Comparison to Trivy. I've not actually used Trivy before. Brian, have you checked out Trivy?
No, it's new to me. It looks like it's an open source security scanner. So I think more on the lines of an SCA type of tool. So as we discussed, SCA or software composition analysis is a super important aspect of your security program. It is not where we typically focus as a dynamic testing tool, where we're focused on what is exploitable in the running application. But yeah, I'm sure the Trivy would be a good complement.
Yeah, it looks like just taking a quick look at Trivy, they cover container image scanning, file system, Git repos, Kubernetes, and so forth. One thing that they don't cover is dynamic application security testing. So I guess that would be the big difference between the two tools. And then the GitHub integration with static analysis and our DAST analysis is I think something else that's not covered by Trivy.
Awesome. Thanks for all the great questions. We'll see everybody next time on our next office hours. Appreciate it.
Thanks, everyone. Caw-caw,
Caw-caw,
as we say.